So, Apratim, you've been working with low power design team right now at Western Digital. So, when you say low power for analog circuits or mixed signal circuits, especially, so what's the difference? I mean, what are the enhancements that add up to make the circuits low power when compared to normal circuits?
So actually, to clarify, I'm not working with low power team basically. So I am working in IoT basically, right? So NAND, SanDisk, Western Digital is known for SSD, NAND flash memory. So primarily, I'm working with the IOs. Yeah. So IOs basically is like input output, right? The data's that you talk to, right? You talk to a computer, that computer communicates to a memory controller, and the memory controller talks to your memory, right? So that interaction happens through IO, and that requires a lot of high-speed data transfer, and DDR is one of the protocol which is like a parallel interface, and I'm working with that. Low power is obviously definitely one part of it, that because you talk about a lot of handheld devices, right? Or especially SSDs, which are like pen drives or something, right? Which are like handheld devices or like removable devices, and they want to go for as low as possible. So you, even in DDR, there is one aspect of DDR called LPDDR. So that's kind of another protocol, which is a low power DDR, right? So yeah, so for any handheld device, you go for a low power aspect of it, right? Now, how do you go for a low power? That is like a lot of things you do. You scale down your probably your voltage, right? Now, when you scale down your voltage, definitely your digital circuits become more slower, right? Now you have to improve your process and all those things, right? Or you can play with your frequency, but then again, playing with your frequency, like toning down your frequency, will tone down your performance and everything. So you do a lot of things. One big aspect of today, when we talk about low power, is we want the leakage power when a system is off, let's say, right? When the system is not interacting, right? So that time, even if your voltage is there, right, you need that voltage, that power supply not to leak, right? So it shouldn't your system which is not doing anything, your system which is not talking to the processor or something, should not leak power. So leakage power, that's what we call, right? The leakage power is one of the biggest concerns today, because dynamic power you can take care by different things, but leakage power primarily depends on the process or something. Because as you go faster and faster in technology, right, you scale down your VT. Now, what happens if you scale down your VT? Obviously, you make your circuit to go faster, which is required for a high-speed design, but you also have a lot of leakages coming in to the picture, right? Now, to deal with that, what you do is you have a lot of these foot switches, or this thing, where primary thing is to isolate the power or the ground from the circuit, right? So that way you kind of bring down the leakage. But then you have to again make sure that when you are in operating region, that foot switch or the head switch doesn't go and corrupt your normal operation, right? So these are a lot of things you go and do. Like you can also think like, can I power down my rail? And let's say before I just start communicating, can I power it up again? But you have to need a sequencing for that. So you do a lot of things. Primarily, you have the knobs like voltage, frequency, leakage reduction, and all these things as your thing. But again, that depends on your thing. It depends a lot about what system are you dealing with. Just to give you an example, since I have spent like 4+ years in PMIC, right? We used to deal with a lot of this power related thing, right? When a processor is powering up, it is taking a huge inrush current. So it's kind of a load step for your PMIC, correct? So how you deal with it is very important. right? So low power itself, how can you achieve, is a very vast topic, and it depends on the system. But that low power mode, when it will come, right, from a functional mode to a low power mode, that transition requires a lot of understanding on the system point of view. Let's say you cannot make a low power mode to functional mode very fast, because that will increase your inrush current to be very high, and probably your regulators, which are probably powering up your circuit, will not be able to sustain that kind of a load step. So yeah, it depends on a lot of things, but yeah, for a processor and all, where the inrush current is very high, where your functional mode requires a lot of current, so the sequencing or staggering of those are very important. So going to low power mode is important, but how you come out of that low power mode is also very important. So your methodology depends on what is the system requirement, basically.
Yeah, that does give a better perspective of low power design, and also it was insightful. So you were very much interested in analog design right from the beginning, and you also talked about a scenario where you were from starting, you went to your professor and talked about papers that you wanted to work upon right from the first day. So right from the beginning, what were some of the sources which you remember that helped you master analog design skills? Any books or any lectures that you watched, or any courses you can just mention?
So okay, so I'll tell you very frankly, right? If
Yeah,
you
even
are
papers
interested,
as well. Even papers as well. Yeah.
sure. I'll tell you. So I have very basic fundamental thing that I'll tell every people who are interested in analog design. First of all, make sure that your BTech knowledge is good, like especially in network theory, even digital logic, analog circuits, and all these things. So your network theory, especially, right? Even some amount of signal system, control system, and all, right? Because control system, linear control system is very important. And network theory, I think RC, RLC circuit. Even today, if I go for an interview for analog design, they will go back to the first question will be from RC, RLC. So if you're going for analog design, make sure that you have done these subject, the gate preparation very well. So for that, you can go for Cannodia or any previous year gate questions or something. Make sure that your RC concepts are very, very fundamentally strong. So that's the first thing. There is a prerequisite for analog, firstly, right? Second thing is probably before going to analog circuits, you can start with digital circuits, because that is also a transistor based thing. Because what we do in BTech is analog circuits, right? Now then in MTech we come to analog IC design. So from the op amp becomes a transistor op amp, right? So that kind of a very big shift, right? So what fundamentally I say that first get accustomed with the transistor level circuit. Now, before going to linear circuit, start with a non-linear circuit, which is easier to start with. So go and do RABE for digital IC design. So the inverter part of it, and or the fundamental part of the RABE is a wonderful place to start ramping up on transistor-based circuits. Maybe it's non-linear, but it's going to help you, right? Even the latches and everything, right? So that's the second part of it. The third part, when you're comfortable with these things, probably start with Razavi. Now, Razavi, nobody has, at least I met nobody, even with 10 plus years of experience, who have completely gone through Razavi, everything. No, it's practically impossible, but start with it. Probably start with a single stage amplifier, then differential amplifier, probably cascodes, probably feedback system, noises, all these things. So Razavi is a book to go for starting analog IC design. Correct. So these are the fundamental things used to start before you think that I want to become an analog design engineer. Make sure that you're comfortable in all these things, right? Apart from that, yeah, obviously you have like wonderful lectures by Professor Nagendra Krishnapura, Professor Shanti Pawan, Professor Anirudhan, who are the pioneers of analog design in India, right? So they are like IIT Madras professors, they are pioneers in analog design. you can go with the analog circuit design course, then analog IC design course, whichever you like, right? And they are like wonderful lectures and they make the subject really interesting. Now, all these things are like your foundation, right? So once you have done all these things, probably start to understand what part of analog I'm interested in. Like, I started with power management IC, which is like I started with LDO, which is a linear regulator, and it comes under probably a power management IC. And I got my internship in PMIC team. Though I never worked in LDO, I was working in SMPS, which is switching regulator. But that helped me to understand line regulation, load regulation, all of these things. Because even as a fresher analog design engineer, you need to understand what kind of circuits give you that push. Probably you are interested in clocking circuits. So you will probably have better to do a project in PLL, DLL, probably oscillators and all these things, right? If you are interested in probably power management IC, probably do a linear regulator or DC-DC IC or something. If you're interested in IOs, you can probably work in any protocol like PCI or DDR, but all these things, right? So you need to understand what part of analog you are more interested. You may be interested in thermal sensors. Thermal sensors have a very different kind of a requirement because you will have like a lot of BJTs coming into picture. Like you can just to say that you can have like bias generators. That's a different kind of circuits. You will do, even if you're not doing bias generators in your this thing, you may not be doing bias generators only, but that's choosing one topic and the domain of analog is very important, right? That will give you some insight that what I can expect when I go to industry. Now, having said that, you also need to understand a lot of fundamentals. You may say that, okay, I'm not sure that which part of analog I'm interested in, but I want to do a lot of fundamental circuits. So my suggestion will be go and grab a kind of op-amp and try to get a good compensation technique, right? Play with the compensation, play with the pole sensing, make sure that you understand all of it. And then probably that kind of a project will help you enter into multiple kind of analog design roles. You can enter into a probably more fundamental analog design role, or you can enter into a PMIC team or anything else. So if you're not clear which part of analog you're interested in, might find some do a very good op-amp design with different kinds of probably compensation, do a band gap reference generator and all these things, explore. But if you know which kind of analog I'm interested in, then go and do that kind of a thing. That will just not give you interest on analog design, but on the whole system. And for that, I'll say that I used to refer to a lot of IEEE transaction papers. And for the fundamental thing for IEEE transaction paper, I will say that go for transaction papers which are not more than 2 years old. So you get a understanding that which are the latest trends in that topic. Because I was very clear that I wanted to start with PMIC and LDO was something that I want to work in. So I wanted to understand what is happening in LDO today, like what are the kind of LDOs coming today. And I have referred to most of the papers which are like 1 or 2 years old.
Yeah, that makes sense because when we are willing to study cutting edge research that's going on in any particular field, we should first choose that field so that we can go and see those papers and read those papers. Yeah, that helps a lot. And thank you, Apratim, for the answer. So for students who are who have no access to tools, even if they are very well versed with the concepts, let's say all the basics that you have talked about, and even they've gone through those books which you have referred to, Rabe and Bezad, Razavi, and also those lectures. But finally, if they don't have the access to tools, they may not be able to do some interesting projects. So what do you say about these kind of students wherein they have got good concepts, but they haven't implemented good projects? So what are the job prospects for these kind of students, and how do they approach? How do they have to approach when they want to get into analog design roles?
I think that's a very valid question, especially for Indian context, right? Because as I told, like most of the colleges, like handful of colleges have this kind of infrastructure that I'm talking about, right? Let's say you don't have that. Huh? So for a digital, if you're aiming for a digital profile, it's very easy because you have a lot of open access tools, especially front end. You have Xilinx tool and Xilinx Vivado and all, and you can also set up a FPGA. Like you can buy an FPGA kit and start working on it, right? That's kind of an easy thing to do. Maybe you're not going to work on ASICs, but it's okay. It's good for a fundamental level that you start with the FPGA tool, and you can get a lot of insights from that, right? Again, digital backend is a bit difficult because those are primarily tool dependent. Okay, very frankly, for analog, I will say that it's difficult without tool, but you have some good tools like LT-Spice, which is a free tool, right? So, and I have done that as well. That you have a lot of these. I forgot. There are some models which are open source model of transistors. Yeah, those are like mathematical models, not the actual foundry models, but mathematical models, right? And those, I think they are developed at Purdue University, right? You can get those models, probably 90 nanometer, 45 nanometer, or 20 nanometer, integrate with LT-Spice, and probably try to do a good project out of it. That, on a fundamental level, will give you a lot of things. So that's the first thing you can do, right? The second thing, I know a lot of these institutes and small companies, right? They are constant requirement of internships, right? So probably don't look at the stipend that time. Probably the stipend will not be as good as like very lucrative like of a tier 1 semiconductor company, right? But try to get some exposure, because what happens when you go for an internship, right? Even as in a VLSI startup or a service company, right? That you get to first expose to the practical aspects and the projects, live projects. And secondly, you get access to those tools. So in that way, you are contributing to the company, helping them to in their projects through your internship, and you are also getting exposed to the tools. So if you absolutely don't have these access to the tool, my suggestion is try with the free version of the tools which are available in the market, and get to the fundamental level to that you get an internship, and then you can scale it from there. So yeah, that's my take on that.
Yeah, that should help a lot of students, because I guess many of the students wouldn't know about those integrations of the technology nodes from Purdue to LT-Spice. Maybe that should help the students who didn't know that before. Yeah, thank you for that. And talking about automation now, design automation. So we know that a lot of automation is going into digital design nowadays. So do you see any such automation happening in analog design, or will it be just the custom design always as it was?
Probably the most difficult part of automating an analog design is it's not right or wrong in analog, right? Yeah, it's very easy to verify a digital thing, right? Even if you see verification today, right? It's very easy to verify a digital thing because you know whether it should be 1 or 0, right? But the understanding of digital, the difficulty comes from the platform or from a system, because the system is so complex today. The digital systems are getting so complex, so many states in the design and all, right? The state machines are getting complex and complex, that you need to understand a lot. It's like an ocean, right? But the broadness is very high, right? But when you go to that state, you know exactly whether it should be 1 or 0, right? For analog, it's not like that. It is like, if you have a bias margin, let's say you want to bias a circuit where, let's say, 12 millivolt. I'm just giving a random number, right? 12 millivolt, let's say, right? It becomes 13 millivolt, you don't know how things will go. It will have some tolerance, obviously I'm saying, but let's say it goes beyond tolerance, let's say 20% tolerance, right? So let's say 12 becomes 15 million. You don't know how things will go. So you cannot write a checker based on that. Or let's say the technology node changes. Today, a lot of work goes in an analog industry in porting the design. In digital, let's say you're porting a design from 7 nanometer to 5 nanometer. It's like a script, right? You just write a script, all the transistor get replaced, 7 nanometer transistor get replaced by 5 nanometer, and then you do with the verification. Probably you need to do some amount of timing verification because the timing will change and all, but it's pretty straightforward. For analog, when you're going from 7 nanometer to 5 nanometer, it becomes even more difficult because now you don't know how the bias margins will be, how the GM is going to change, how the ROIs have gone, right? But you need the performance to be same, right? But your transistor has changed, right? That's the difficulty of scaling. Now, that's the circuit part of it. From a layout part of it, everything is hand-drawn because your power or your signals, right? It needs to understand where you need to have an exact matching. So that is possible only when a human is looking at it, right? Because it's not a machine who is doing that, and you cannot just write a constraint and say that, hey, I just need these two signals to be matched exactly, because there is nothing called exact matching, right? So that's the layout part of it. Verification part of it, again, as I said, right? You can't write a checker. So analog mixed signal verification engineers need to understand every part of the system, how the analog circuit should work. Even if you're writing a Verilog A model, right? You need to mimic that model exactly like a analog circuit. Otherwise, you'll never get a proper result, right? And the fourth difficulty of automating is, as I told, right, the world is digital, right? So your processor or any big chip is digital, and analog is sitting in that digital part just for the giving the probably the clock or the power or anything like the IOs or something, right? Now, the fundamentals of the chip, most of the chips where the analog is embedded within that chip, those chips are digital, and the technology node they're working in, right, are digital nodes. Like when you are doing a 7 nanometer or a 5 nanometer, or we talk about 10 nanometer, this foundry is mostly concerned about how fast I can switch. So they are making a switch, right? And you probably will not get the analog characteristics to be very good at that point, right? When you are doing an analog in 90 nanometer, your transistors are fundamentally very good for analog. But for 10 nanometer, 7 nanometer, it's like your mathematics doesn't work over there. You have a lot of nonlinear effects coming into picture, and those are not ideally analog technology nodes. But you need to do analog in those technology nodes because your analog is sitting in a digital circuit, right? So that makes technologically very difficult. So we have a circuit difficulty, layout difficulty, verification difficulty, and most important, the technological difficulty in making analog as automated as digital. But we are doing a lot of part of it. Like we are fundamentally reusing a lot of blocks and all. But still, it's a long time. And as we are moving forward, right, I see that it's getting difficult, and analog has to be more custom made than ever.
So do you say that it's tough work for analog engineers?
It's not tougher. That is why we are having jobs. I think fundamentally we will lose our job if analog becomes that much, because you won't need this many analog design engineers. Because I said a lot of analog industry is surviving because there are a lot of porting requirement. If you're going from let's say 10 nanometer to a 7 nanometer process, fundamentally a lot of things changes, and that requires intervention of analog design engineers. Tomorrow, if a script can do, I don't know, maybe I will lose my job. So I need to search for a career in digital industry. So I will not say that's the difficult part, but that's the reason we exist, and that's the fundamental joy of being an analog design engineer, to see how your circuit can tolerate and even your technology not changes, how can you tweak that circuit to work in that technology? So that's it.
Yep, got it. So you mentioned about scripts, and when we talked about automation. So I've seen a lot of interns who were in digital. They've written Python scripts and does some project with those under internships, and also they've used machine learning as well. So do these two skills, Python and machine learning, are these also applicable in analog design? Any part of analog design where you have to characterize some parts of the circuit and make it I mean make it very good, very characterizable, and yeah, in that sense.
Yeah, I understood your question. I'll tell you very frankly, right? So when I did my master very early, right? I did my masters in 2016-18 time frame, which is like 4 years before, right? That time I didn't learn Python. We had Perl TCL, right? But in 2018, 18 after 2018, VIT realized that Python is coming up, and they included Python. Today, my juniors study Python, right? So what I'll tell, when I got into industry, Perl and TCL was the cake, right? Every person was using Perl and TCL. Now you see a lot of people are using Python. So the industry is that much dynamic. In 4 years, you see that the scripting itself has changed a lot, right? So so that's the thing. Now machine learning is coming. I know that MTech VLSI curriculum is now including machine learning, right? Because they have realized that this is now the need of the hour. And you don't know, like 4 years down the line, probably you will have a lot of other subjects which are required in VLSI design, which is related to machine learning, right? Earlier, the most of the industry who use machine learning in VLSI was the EDA company, because the EDA tools requires a lot of place and route and all algorithms based on machine learning, right? But today you see even the product companies, when they're doing a lot of machine learning. Scripting is done in Python. Though Perl and TCL are still used, but Python has taken over a lot of important places, right? So that's how the dynamic it is, right? Now, I'll tell what scripting is. Scripting is itself not a skill or a domain. Scripting is a skill, right? I'm an analog design engineer where I need to write a lot less code than in a digital design engineer. Even for me, if I have to hack a netlist, right? Let's say I need to hack a SPF netlist, I can do it only by scripting. So even as an analog design engineer, if I need to hack a netlist or do a kind of a search replace operation, I have to do through a scripting, correct? Because it's fundamentally not possible for a human to go through that whole SPF and all, right? So scripting is a skill, right? Not a domain. The reason a lot of interns do the scripting, because physical design team or even verification team, emulation team, right? Even layout team, analog layout team, they need to do a lot of automation so that the repetitive work doesn't need to be executed by human, because that's a loss of productivity, right? So they do this, they give this job to the interns. So if a physical design team got an intern, the probably manager will think that, okay, I have 5 scripts to be written. These tasks can be automated. Why not? Because he or she who is doing an internship, they have done scripting in their college, right? Why not just make them write that script? And scripting is a very, very nice way to judge someone, like how they think, how fast they think, right? So that's a way of like engaging interns, right? But I'm sure when that intern, he or she will be integrated in the team as a full-time engineer, they will not just write scripts, right? Scripts is a part of your job in VLSI industry. If you have to survive, you have to write scripts. It can be Perl, it can be TCL, it can be Python. Probably I'll not write a script for developing a tool, a CAD engineer might need to know that what exactly is scripting language I need to use. Probably they will need a skill language, they need a Python language. But even for someone who will not develop that tool, like me, I'm not a CAD engineer. Even for me, I will need some scripting knowledge because I need to automate my work. I don't want that work to repetitive works to eat on my productivity. So I'll write some script. So yeah, so scripting is a fundamentally necessity for any VLSI design engineer. But whether you need to do it through Python or not, or any you need to know new languages or not, is depends on your domain again.
Yeah, got it, Abdul. So questions before we call it a day. So with the current scenario in India and VLSI design, and we also know that India's semiconductor mission is on the rise. So what do you think about VLSI industry in India in coming 5 years, let's say, both with related to both the job prospects in VLSI and as well as the advancements that are going to happen in India from India?
Yeah, sure. So I'll tell you from a global perspective first, right? Not just India. If you see US, right, CHIPS Act came, right? You see Taiwan, such a small country, became such a powerful country because of TSMC, MediaTek, and VLSI industries, right? So people have realized that electronics, like oil in the last decade, electronics is kind of semiconductor, I'll say, is kind of the most important aspect of any economy and power, right? And India being the nation which is growing every day, right, cannot stay behind, right? We have already missed the bus in terms of fabrication. Today, we don't have a fab in India. India being one of the most resource capital and one of the most intellectual capital of VLSI industry, right? We don't have a fab in India, right? So we are trying to do everything to bring fab in India, right? I don't know whether we will be successful or not. I hope that we become successful. But India, what India has done very well is it has set up all the design centers. You see all the big companies, be it Qualcomm, be it Intel, be it Broadcom, be it Western Digital, Micron, Samsung, every company, you name it, NXP, Infineon, Texas Instruments, every company got their design centers in India. And probably these Indian design centers are probably the second largest or the third largest design centers outside US, right? Intel has got probably the second largest in India, right? So most of the companies, they have the second largest or the third largest. So Indian brains are contributing to the design of the chips, right? Fab, I don't know whether we will be successful, but design way, we are successful already. And we are moving even further. If you see today the tech leaders, Intel have a lot of principal engineers in India. You even have senior principal engineers and fellows in India, right? Western Digital got distinguished engineer, a lot of technologists and senior technologists in India, right? Synopsys have got a lot of tech leaders from India. They are the individual contributors. They are we have not just got VPs and senior directors. We also got tech leaders who are highly accomplished engineers in India. They are made from India, right? So they are bringing more and more because these companies have realized that India is filled with talent and they are investing in Indian talents even more. When they need human capital, they are relying on India. And this is even increasing today. And I think this is the perfect time for any engineer who is interested in VLSI and semiconductor to be part of this industry. Because what you will witness today, being a part of industry, is something that probably the software guys have witnessed in the 90s or early 2000s. When the dot-com era or the boom happened, right? That is a time when the software industry like just bomb blasted. Like in India, it was. Today we see that every all this for every Uber you have a Ola, right? For Amazon you have got this Flipkart, correct? So this is, and they are the international brands today, right? Why this has happened? Because that time these highly accomplished engineers came and invested in India, and India became the breeding ground. And today software has gone to that level. Semiconductor is going to have that same thing now. And I can tell you probably 10 years, 15 years down the line, when you will be in a position like a senior manager position, you will see the same thing which you are seeing today for software, right? And you are part of shaping that for semiconductor for India. So even if we want to be one of the, we start fab in India, but even if it doesn't happen, the design industry is going to get a very big boom. So my suggestion to fresher is just give it a thought that come to semiconductor industry, get those skills, because semiconductor requires those skills, very fundamental niche skills. So get those skills, and very sadly, we have not democratized those skills. It's very difficult. I think VLSI for all, I love that title, VLSI for all. So democratizing VLSI to every student who are interested, right? That's the goal, right?
We can use that as a tagline.
Correct. So that's what I also believe, that we should, like today software is not anymore kind of a hidden thing, right? Anybody, even a school going student can learn software development. They can know coding. So sadly today we don't have that for semiconductor, but we still have ample of opportunities, and do use those opportunities, get internship and get to this industry, because 15 years down the line, we are going to get to that position where semiconductor is a key industry for India, and we are going to be like, we are going to change the way people look at semiconductor.
Yeah, that's actually insightful and also motivational as well. And that should build up a lot of confidence in the students who are just starting out, especially freshers who are very much interested into VLSI, that this VLSI trend in design, especially from India, is just going to go up. If you also just put the fab aside, but the design part is going, this is going to improve, as you're saying. Yeah, thank you for that, Apratim.
Right. And another part is like, when I say design, a lot of my friends say verification is also going up. I mean, design means everything that goes in, like design, verification, everything. Even when the chip comes and you do a lot of bench validation, ATE validation, all these things India has got, except for the fab, right? Today, India has got everything, and we are doing end-to-end chip right from India. I cannot reveal, but I can tell you, lot of things that you're using today, right? Like from the processor perspective, memory perspective, GPU perspective, lot of those chips are being made in India end to end, right? We are not anymore a service provider, right? We are not in that mode. The product companies have given India that enough freedom. At least there are a lot of chips are made out of Bangalore, Noida, Hyderabad, and all. Right? So that's a very encouraging trend, and this is just going to grow.
Yeah, that's quite motivational. And in fact, as you said, the whole RTL to JDSI flow has been done by Indian engineers. Yeah, that's true. Yeah, so we're almost at the end of this session now. Just final question for you. So when you look back 5 years ago, when you were just starting out with your career in VLSI, what do you suggest young Apratim who was just starting out with related to life or career specifically, and also any mistakes that you had done within this 5 year span when you've just entered the industry that you want to suggest him not repeat them?
Yeah, interesting question. One thing I'll tell you, right? If I can go 5 years back, I'll happily go because I want to live that life once again, right? And I'm not saying because today my life is boring. I feel like I'll have as much exciting life as I was having 5 years down the line. To be what I will tell my younger self, I'll probably nothing because the mistakes I have done 5 years ago, right, in this first 5 years, I think those mistakes were necessary. Those mistakes, I have learned a lot from those mistakes. How it shaped my career, probably that's the reason I am here today, right? Like whatever mistakes I have done, whatever chances I have got, I'm really very thankful to them. And it was a roller coaster journey. There was times I didn't sleep. Like my design, like I first when I my design came to lab, I still remember it was like a baby, right? My first design, I can never forget that, and it was one of the most difficult design I'll ever do in my life, right? And that also got me my first patent, and I think that first few years was incredible, and that was I did a lot of mistakes, but those mistakes were necessary for me to shape for how I am today, right? Even as a student of MTech VLSI in VIT, I think I've learned a lot. I have done some mistakes, but those were also very necessary, right? And I think what I want, if I given a wish, that my life should be like that 5 years or exciting as 5 years, that I never feel like I'm too experienced and now I can chill. And that's the beauty of being a VLSI design engineer, analog design engineer, that you always feel like you are a fresher. At least when I started with high speed IO, I felt like I never experienced this. People with my age who have spent like 5 years in IO, they are like, okay, they have some background with that. I don't have that background. I come from a very different background. I come from a classical analog design. Will I be able to sustain this? But it was a fantastic journey. This 8 months, I feel like a fresher. Like and that's the beauty of it. I think I will go over again and again, and I'll make sure I'll challenge myself that whether I can do it. This is a new thing for me, and I think that's necessary because tomorrow you don't know what technology is going to overtake you, right? You may be doing like 5 years, 6 years, 10 years down the line. I'll probably write code for machine learning because that probably will be required, or I'll handle a team with bunch of machine learning engineers. They're doing some machine learning algo for the VLSI chips. I probably will do that, and I would love to do that because that will challenge me. Because if I am doing the same thing which I was doing 5 years ago, then there is no fun, right? The technology, we are technologists, right? We need to explore the new aspect of technology, and as technology is changing, we need to change ourselves. So I want to be fresher all my life and learn new skills. And probably I'll tell my present self that be as curious as I was 5 years ago. So that's my take into it. So yeah.
Yeah, that was quite interesting. So learning forever is what technologists should do. Yeah. Thank you, Apratim, for all those insights that you have given us in this session. In fact, I can say that this session was energetic. Your answers were very energetic and they were motivational in many aspects. And also, this was interesting and insightful. So, thank you for spending your time with us in this session and helping all those freshers who have doubts in many aspects, whether it be career related or study related. Probably the answers which you have given in this session should help those students to clear all those doubts. Yeah, thank you for that, Apriti. And we look
Thank you for
forward.
having me. Yeah, yeah. Sorry. Yeah, go ahead.
We look for we look forward to collaborate with you again in near future.
Sure. Thank you for having me. It was a fun discussing with you. I think while answering, right, I also realized a lot of things. Like you question, what will I tell my 5 years old? Right?
Yeah.
So I also realized that, yeah, probably I will not say anything. Probably I need to tell my present self that, okay, be curious, right? So that's the thing, right? And I just had fun having this conversation with you, and I love spending time having this conversation. And I think VLSI for all, I love the tagline, VLSI for all, the name itself. And yeah, so I sincerely wish all of you all the best. And also people who are watching this, right, I'm always reachable in LinkedIn. Just if you have anything, just reach to me over LinkedIn. I would love to have a conversation. If you need any, if I can help anyway, because I am also not too much experience, right, in this industry. I probably have 5 years of experience, but if I can help you and I can understand a fresher very well, because I'm not too old also, right? So I can understand what are the pain points you are going through. So if you want to reach out to me, please reach out to me in LinkedIn. And all the best to VLSI for all. I sincerely wish you guys all the best, and maybe your venture makes the thing VLSI for all, right? People who are interested in VLSI should get an opportunity in the industry. So I'll love to collaborate with you even in the future. So thank you for having me.
Yeah. Thank you, Apratim, for those kind words. Yeah. So thank you guys for joining us for this session. Stay tuned for more such sessions about VLSI, expert talks coming up. Thank you all. Bye.